So he is my one of the youngest developer. So the entire DSC work initially we were team. Now he is handling.
And both these boxes are entangled.
I think thank you for keeping the energy flowing. I think it's what almost 4 o'clock. I won't keep you away from your chai for long. But before we go for break for the tea, I want to introduce to us to all of you Rumit Shah. Some of you would know him. Some of you perhaps are his customers. He's one of the founders who worked on deep tech. I mean, he actually built HSMs from almost 9 years now. Many successful deployments, hardware security modules, many successful deployments, very varied use cases from PETs to identity to now CBOM and everything else, right? So they've been doing foundational work in cryptography for many years now. And just recently, I'm very happy to report to all of you that they've just got FIPS 143 certification in their own name, which is actually very difficult for any company to achieve, right, from India. So I would like to invite Rumit on stage for a session on what is the impact of quantum on infrastructure and what we need to be looking out for. Rumit, over to you.
Name is Rumit. I represent a company called GSA Softtech. We are an Indian OEM for HSM, hardware security module. That's what we started with. And today's topic is around quantum safe infrastructure. That's the topic which we have taken today. Since morning, there's been a lot of topics, and I would like to thank DSCI, FINSEC, to arrange this quantum resilience workshop, because everybody in the ecosystem is aware about quantum, but they are not aware about that what they should do with this quantum threat or whatever is been there. So, presentation. Okay. Let me start the presentation. That's how. So today's topic, which we have, is around quantum safe infrastructure, and how we'll be able to make sure that we go beyond the dependencies, and how we'll be able to find out, and how we'll be able to smoothly transfer to the quantum ecosystems. Firstly, over a period of the whole day, you would be aware about that quantum computing is not part of only future. Now we have to act right now. It's not the threat which would come, and we can take time to mitigate those things. So the threat is now, because whatever algorithm which we use across in the system is RSA and ECC, which is being used across for most of the activities. And activities which we say across is around data in transit. If we say data in transit is heavily dependent on this particular algorithms, which is RSA, ECC, ECDH, key exchange algorithm. That is where the main problem will lie, because we connect it to the edge devices. The infrastructure is hosted in a particular environment of a bank or a financial institution. We connect it to the device, their institutions via a edge device, and that works on this particular cryptography, and that's where the threat lies. The data which has been pushed across in this particular ecosystem is sensitive data. Some data might be short-lived data. Some data would be a long-lived data. Like, if I do a KYC of mine, and it has been taken across on we say about. Okay, so hello. if I do a KYC of mine today, and if we see the data is being transferred from the edge device to the servers of bank financial institution, my KYC, I am not going to change my address for next 7 years, 10 years. It might happen, I might change, I might not change. So now if somebody gets hold of this data, right now, it is not decryptable, it would not be decrypted, but once the quantum computer comes in place, it would be able to decrypt this data. So there is a threat for this data which has been done, and the threat is now. It is not a future, the threat is right now, because the data is already been started capturing. So that's the topic of harvest now, decrypt later. That's what comes across. So data has been captured right now in this, and that's where we have the issue. The other issue which organization understands is that organization feels that they know where is the cryptography, but ideally they are not actually aware about the where exactly is the cryptography used across. That's the next topic which I will have on this. Harvest now, decrypt later, which is the which we have today, is about the financial institution collects a lot of data, and it can be all kind of information of a person which has been captured. This is not only restricted to only banking and financial institution. It would be applied to each and every institution which is collecting data. However, the more risk is associated to financial informations, because that is associated with money, wherein you would be, that threat would be associated with over there in this. So data has been right now been captured. It works on a TLS traffic. So TLS traffic we can capture across the data. Of course, at this particular time, we are not able to decrypt this data, but we can always harvest this data, and actors have now started already harvesting this data. Once the data has been harvested, and Google has already told that by 2029, they would be able, they means the quantum computer will be able to break the current algorithms which are there. So for that, we have to act right now. I'll just give a small example of of course, a banking environment wherein in some RFPs there are some requirement which has been mentioned that data in transit encryption to be taken care. Okay, what currently everybody does is data in transit has been taken care by TLS certificate. So we don't have to worry more. The data in transit would be taken care over there, and they don't have to apply any kind of a special encryption in data in transit, for an application level encryption or such thing. Nobody goes for those kind of techniques. They just rely on the TLS 1.2, 1.3, that kind of architecture. Now here the main challenge lies, because TLS works on either on RSA or ECC. TLS is not still gone across to PQC key exchange. What happens in this TLS is it generates a session key, and session key has been first, there is a key exchange which happens and generates a session key via which the data can be encrypted, and then it can be transferred. And over there they will be able to decrypt this session key with the public key or private key which is bank is hosting, and then they are able to decrypt the data. This is the normal architecture of any kind of an key exchange based encryption. Here what is happening, because the algorithms which are being used is ECC or RSA, the data which has been encrypted, even by which has been encrypted with TLS channel, would get decrypted later on when the quantum computing comes in place. That's why we have to act now and make sure that we need to identify where all things, because which all places we use this kind of an activity or the cryptography, so that we can mitigate those things. that's where we come across to the next topic, the invisible cryptography. That's the problem which we have. We don't know where is our cryptography and how it is being used. So if you see in a typical banking environment, you would have a core banking, you will have an ATM networks, you will have internet banking, mobile banking, VPN infrastructures, it can be DevOps pipeline, those kind of environments, payment systems. So all this kind of environments has the cryptography which can be used across for their data in transit encryption. But we are not been able to concentrate on that which kind of cryptography has been used across in this, or we are not been able to see also because it's all invisible. It happens. We go to ATM card, take an ATM card, go to an ATM, do the transaction. At the background, it is happening on some cryptography. Okay, it would be ECC, TLS, or whatever cryptography they might be used, or custom cryptography. But there would be some cryptography which would be used across to do this transaction. All these transactions or all these environments which is there in the bank, it's all using cryptography. Even each and every smallest of application in a bank would be using across a cryptography to do activities. Now this cryptography does not only mean that we would have the ECC or RSA, it might also mean the libraries which is being used across in this. It also means across the HSMs which is being used across to protect the cryptographic keys. It also means the key management system if they have that systems also. All these places are right now at a threat. That's where the invisible cryptography problem lies. To move towards the quantum safe infrastructure, we would have to cater to these 6 points. One is about discovery and create the crypto bomb. So we can identify all across where is our cryptography, scan it out, everything, create the inventory out of it, and this is a continuous process. It would not be a one-time process, it would be a continuous process wherein you will be able to scan out everything, and on a periodic basis you will be able to take it across. Then implement a key management system or a first HSM to protect the key, but mainly first implement a key management system so you can have the key orchestrations done across where all your cryptography lies, and then protect those keys using HSM. So you create HSM root of trust and then protect those keys using HSM over there. Currently also it is happening in a critical infrastructure. All data or all cryptographic keys which are critical in nature, they gets protected using HSM. Like UPI transaction happens at the background as HSM over there. Or your, if you say about your check truncation transaction, happens at the background as HSM over there, which is storing the key. So protection has to be taken care as over there for the cryptographic keys. So discovery, C-bomb, which is cryptographic bomb, and then we do key protection using HSM. Then we do enterprise key management, where key orchestration can be done across at one thing, which can give you the crypto agility in terms of you will be able to move to a higher cryptography without changing your system. If you will put across a key management system, key migration to a higher algorithm, which would be easier. Just giving an example to that, the TLS which we will be using, or maybe a database encryption which we might be using across, they use across right now a native license of them where they use their encryption key locally. This key can be protected with the key management system to protect the key. But the encryption which happens over there, sometimes some database providers does the encryption using 128-bit AES key, which is weak in nature. Overall, it has been suggested to use a 256-bit key and 128-bit of encryption that would come across over there when you use across a 256-bit of key over there. So this are all invisible in nature, so we have to make sure that we use across this. PKI and certificate authorities, we need to have PKI setup in or within the organization and the public setups which can generate hybrid certificates, which can generate the post-quantum cryptography certificates, which would help us in doing our own authentication more clear way. And then comes across the example which is the data and application securities. So we should have the database encryption, we should have file encryption, tokenization, secrets, API-based authentication, API-based encryption over there. All this thing happening over within the system with making sure that the data which is being pushed across from one place to another, from the edge device to the servers, are being protected in a way that the key exchange which is used across in this is a post-quantum key exchange. We need to have this systems over there. So, but this is very critical that we need to have these systems implemented. And then governance and monitoring. Like I said earlier, that discovery is one part, but we will have to have continuous discovery, governance, and monitoring policies around this. We need to also follow the country-specific guidelines for using the cryptography. Why inventories matters? Okay. We can, you might have gone through with a lot of DPDP guidelines and those activities. What DPDP guidelines suggest is that you need to first know your data. Then only you will be able to act on that data and protect it. Similarly, in cryptography also, you need to first know where is your cryptography. Once you will identify this cryptography, you will be able to protect and create the cryptographic protection layer towards it. That's where the need of cryptography inventory is very critical in nature. HSM with PQC support. HSMs are now, current HSMs are RSA, ECC, AES, those kind of algorithms are there, used across for key protection, encryption, and signing. These HSMs need to now support, and you should take across such a way that HSM should support the hybrid cryptography. It should support MLKM, MLDSA, and the other PQC algorithms which can be there. It should be firmware upgradable, so that whichever HSM you buy right now, it is crypto agile to the next algorithm, as well as it can have the future algorithms built in capability over there by doing upgradations on that. Crypto agility is one point which is required in the HSM. Key management system is again a very critical system, wherein you will have to have the centralized algorithm control. Then you will have automatic cryptographic policy management, which can help you in doing these activities. Then hybrid key lifecycle management, that would come across in place, because you will have to do the hybrid key management based on this. If you wanted to do a key migration or any mitigation policies in your organization, you will have to understand what is the cryptography right now, decide what need to be done across to that particular cryptography, and then you will have to migrate to hybrid certificates, and then also have the capability of rolling back. Okay, if something goes wrong, then you should have capability of rolling back the keys. PKI, as I said, PKI authorities or certificate authorities need to evolve and come across to give across the hybrid certificate first, which India is on the advanced stage, which we will get across soon. And we should also have the PQC certificates with this. What changes and what does not change? Okay, so your cryptographic algorithm changes, your TLS handshaking changes, your digital signature schema changes, your key exchange mechanism will change, your certificate structures will change. Okay, but what does not change, what remains as it is your zero trust principles, your identity governance, your access management, your security monitoring, your segmentation strategies. That would not change. This is only about the cryptographic change which would happen to make sure that we mitigate to the risk which is coming. Impacted areas which are there, which you will buy VPN, TLS infrastructure, SSH environment, machine identities, API securities, then service to service authentication. These are the areas which would require the first attention, and that would come across as a transition phase. What would be the transition model which can come across? The hybrid cryptography is the first model which we'll have to take across. Then gradually migrate, do POCs and those kind of things. We have to gradually migrate. Parallel trust models we'll have to create with hybrid and those, and then control interpretability between this. An enterprise requirement right now is, one is minimum disruption. Wherever we are going to implement, we should have minimum disruptions. Maintain trust continuity, and then of course have the backward compatibility, which is very critical, because if something happens, you should be able to go back. Legacy Belkey system has these problems like core banking, COBOL applications, ATM middleware, Shift gateways. Those kind of things are there, and which have the challenges of hard-coded certificates, vendor control integrations, unsupported libraries, which comes like if you wanted to support a PQC library, you will have to move across to OpenSSL 3.5, then only you will be able to support. Otherwise, you will not be able to take across. So these are the challenges which are therein. This is the plan which would happen. You discover all your cryptographic dependencies, then you will be able to classify what are the risks associated to this, and then classify the risk according to the usability of the applications or those. Build a crypto inventory. It does not include only certificates or key. It would include all your libraries, your certificates, keys, secrets, protocols, algorithms, all kind of crypto inventory will come. Introduce hybrid cryptography, which would help you to mitigate. So like you put across TLS on TLS 1.3, if you can put across ML-KIM based key exchange, so your minimum risk would be there. So, and then also you will be able to maintain across that is a hybrid approach which you can take it across. Modernize the edge infrastructure first. That is the most critical factor, because that would affect the first. If I'm operating from my mobile or a laptop, some kind of banking application or a financial application, that is the first risk which we have, because that's where data can get harvested and then decrypted later. So we need to modernize this as first, and then gradual back-end transformations which might have to happen. Crypto agility lifecycle: discover, access, classify, transition, then monitor, rotate, then retire and comply. Retire means you will outdate those certificates, and then certificates or keys or algorithms, and then comply to the current regulation. That's how is the crypto agility lifecycle will mean. The most critical part would be vendor and procurement implications, okay, which we will have to look across over there. We have to ask this question. Now we'll have to make sure that we ask this question. Whatever application we take or whatever devices which we take, whether it is crypto agile or not. That is the first question for any vendor procurement has to happen. Does it support open standards? A firmware upgradability is possible or not? A PQC roadmap defined or not for that particular organization? Are API interchangeable or interportable? Is migration flexibility supported? Okay, these are the main question, because we should not get into a case where we become vendor lock-in. That's the common challenge across the industry, that vendor locking, vendor tries to lock in the customer, and then even though there are RFP terms, Later on, we are not able to change this thing. That's the main area. And then recommended standards are this, which are there: FIPS 143, PKSS 11, KMIP, and Open APIs. This is again repeat of things. I'll put across the end to the thing and open up across for questions, if any. And then modernize the strategies. That's how the focus will be there. Thank you. There's a worksheet given over there, and it would be according to the slides which I have taken across. You can see and try to fill those worksheets to understand your own organization's cryptographic posture management. Maybe you can try that out and you might get across the results out of that. Thank you.
Based on what he delivered, you will please fill it up for into your enterprise.